Here's a little homework help on problem number 17. This is from lesson 6.1. We are doing graphs of exponential growth, and this is actually a transformation of a parent exponential growth function. So the way I want you to treat these is I want you to show me the parent and then have an understanding of how this parent is being transformed. So I'm going to take you through a step-by-step table process for getting to the final answer. So first of all, understand that this involves the parent f of x equals 3 to the x power. So I'm going to make a table for that parent function using those same domain numbers that we've used before. 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9. If I do -1, I get 1/3. -2, I get 1/9. Okay, now let's talk about this guy. When I multiply, remember using variables, this represents the translation that looks like, or transformation that looks like this. So this number A is going to do, actually in this case it's going to do two things. It's going to do compression because we're multiplying by a number, a decimal, between 0 and 1. But then we also have this negative, which is going to cause a reflection over the x-axis. All we need to be concerned about at this point is this number, -0.4, needs to multiply times each of the y coordinates. Okay, remember, if you have a number that's going to cause stretch or compression, that number needs to multiply times the y coordinates of your parent. So we'll just say it like this: multiply y by -0.4. Okay, so at this point I'm not going to do anything to the x's. I'm just going to walk through this one step at a time. And I'm going to grab my calculator, and each of these y's from my parent table multiply by -0.4. So obviously 1 times -0.4, 3 times -0.4 is -1.2, 9 times -0.4, -3.6, 1/3 times -0.4, -0.133 repeating, and finally we have 1/9 times -0.4, -0.04. All right, so we've taken care of multiplication to create both the flip and the dilation, vertical compression. And now let's do the movements. These are known as translations. So I'm going to be moving 2 places to the left. Okay, so another way to accomplish that is to subtract 2 from each one of my x's. And then I'm going to move 4 places up. So another way to accomplish that is to add 4 to each one of the y's. And so this final table will be the one that I graph from. So I'm going to label it as subtract 2 from x. That's going to be the left 2. Add 4 to y. That's going to be the plus 4. And this will create the table that will get us to our answer. So 0 minus 2, 1 minus 2, 2 minus 2, -1 minus 2, -2 minus 2. Okay? And then we're going to add 4 to each of these. 3.6. -1.2 plus 4, 2.8, -3.6 plus 4, that should be 0.4. Then we have negative 0.13, sorry, we're down here, negative 0.13 plus 4, 3.87. And we'll try to squeeze this last one in. So negative 0.04 plus 4, 3.96. All right, so let's plot these points and we will have the graph for our answer. So negative 2 and then about 3.5. We'll call that 3.6. Negative 1, 2.8, not quite to 3. We'll just guesstimate that to be right there. 0.4, that's about a half. Okay. Negative 3, and then 3.87. 1, 2, 3, here's 4, so just under 4. Negative 4, and then 3.96, so even closer to 4. A little bit further up than this point, but not quite to 4. Really, really close. Okay, so what we have, you can see how its exponential growth flipped over because of the negative. And we now have a horizontal asymptote. Let me go ahead and sketch this graph. Try to hit the points. All right, so since we shifted 4 places up, our original horizontal asymptote was the x-axis, or y equals 0. But we shifted that 4 places up and we flipped the graph over. So now we're approaching y equals 4. You can always get the horizontal asymptote from this k number. We're approaching y equals 4, but we're approaching from the bottom side this time instead of from the top, which is what we normally do whenever this is positive. So that is it. That's your graph for number 17, and it's all about understanding how we take the parent function and then transform it. And if you walk yourself through, I don't want you using a calculator for this to do these inputs. I want you to be able to show me that you have an understanding of the transformation. Now, when I say don't use a calculator, I don't mean in coming up with these points, but I don't want you just to input into X and then try to do all of this to get the outputs. There will come a day in college algebra where you can't use a calculator at all. I want you to be really good at these transformations of parent functions. Okay, so we have the graph, and now we need to show the domain and range. So again, the domain is still the same. You can tell that as we travel on the x-axis to the right and to the left, our graph is going to encompass all of the x-axis. So we can show all real numbers using interval notation. Negative infinity always goes on the left in interval notation. Positive infinity would go to the right. If you use the inequality notation, you could do x, not f of x. All x such that negative infinity, x, positive infinity, or in other words, x is between negative and positive infinity. The range, a little different since our graph has flipped over. Now we have an upper bound number of 4, and we have all of the numbers below 4. So if you're going to use interval notation, once again, you always put negative infinity on the left side. So it's almost like you're coming up from the bottom, and your upper bound, your right side of this interval will be positive 4. And again, we're not going to ever touch positive 4. We're just going to continue to get close to it. That's why this is an asymptote line. So I'm going to leave parentheses here to show 4 is not part of the range. Or you could do f of x such that f of x is less than 4. Either way is okay. All right, so I hope that helps. If you have any questions, let me know.